Hi, my name is Chezambada. Today I'll be presenting about Euclidean geometry, grade 11. So, my introduction goes like this. There's no we can get into grade 11 theorems before we do the revision for grade 10. So, my introduction will be a revision of grade 10 Euclidean geometry. So, at first, we're going to talk about triangles. So we have isosceles triangle. Isosceles triangle is a triangle with two equal opposite sides and two equal opposite angles. So for example, this is the triangle. In this triangle, we are given that AB is equal to AC, and once these two sides are equal, we can conclude that even their equal opposite angles are what? Equal. Is the summary. If AB is equal to AC, we conclude that angle B is equal to angle what? C. The reason for this statement is equal opposite side. Okay, number two, we're gonna talk about the exterior angle of a triangle. So, from this triangle, the exterior angle of this triangle is equal to the sum of two interior opposite what? Angles. So exterior means the what? The outside. So it is the exterior angle. It means that it is the outside what? Angle. So the outside angle is this one, which is D1. This angle is equal to the sum of two interior opposite angles. The interior opposite angles are A and what? B. So, in conclusion, we can say D1, which is the exterior angle. D1 is equal to the sum of what? Two interior, the inside angles, okay? The inside opposite what? Angle. So, D1 is equal to A plus what? B. Okay, that's it. So, let's go to two triangles that are congruent to each other. So, as for congruent triangles, we are given triangle ABC and triangle DEF. We know that we have a lot of triangles a lot of properties of congruent triangles. So I just picked one property here because this property we're gonna use it proving theorem number 1. So in these two triangles, we are given that B is equal to 90 degrees and F is what? 90 degrees as indicated by this rectangle. Okay, B is 90 and F is 90. We are even given that AC is equal to DE and AB is equal to what? DF. So, when we prove this, that these two triangles are congruent, we're going to first talk about what? Angle B. So, angle B is equal to angle F. The reason is what? Given, but we must say B is equal to what? F, and is equal to what? 90 degrees, because we are given that this thing is what? 90 degrees. I mean B is 90 and F is what? 90. And we are even given that AC is equal to what? DE. Here it is. AC is equal to what? DE. We are given that. And the AB is equal to what? DF. AB is DF. We are also given that. Now we have angle and side which are equal from the two triangles. So we can conclude that triangle ABC is congruent to triangle what? DEF. Triangle ABC is congruent to triangle what? DEF. Why? It is because of right angle, hypotenuse, and what side? We know that 90 degrees means what? Right angle. The side opposite to the 90 degree, it is called what? Hypotenuse side. It is the side we can just say side. So that's how you prove the congruency of a triangle. So now we know that angle subtended by a straight line is what? Is supplementary. So here we have a straight line. If we have a straight line subtend an angle of 180. So we can say if here is O and this one, we can say O1 is equals to 180. The reason is what? Is straight line. Okay, now let's get to our first theorem. The first theorem states that the line drawn from center of a circle is perpendicular. The line drawn from center of a circle perpendicular to what? To the chord. That line bisects what? The chord. Here it is. This theorem is saying that the line drawn from center of a circle perpendicular to what? To the chord. Note that AB is our chord, no? The line drawn from center of a circle perpendicular to the chord. They say that this line bisects the chord. And the word bisect means cut something into two equal what? Halves. So we are proving that OM bisect what? AM. This is our required to prove. RTP means required to prove. So on our required to prove, we are proving that AM is equal to what? MB. So when we prove, we must first do what? Construct. This is my construction. By constructing, we join OA and OB. OA and OB, I indicated them with pink lines. Okay? Here's my construction with what? Pink line. Okay, OA is equal to what? OB. And then we mark M1 and M2. So then we prove. When we prove, we know that M1 is 90 degrees. We are given that. If M1 is 90, even here at M2, it must be a 90 degrees. Why? Because 90 plus 90 is what? 180. And angle subtended by a straight line is what? Is 180. Like we said here. Okay. So M1 is equal to M2. They are all equal to what? 90 degrees as I indicated here. OA. If you can check, OA is a radius. This is the radius of a circle because what is a radius? A radius is a line drawn from center of a circle to a what? To a circle. So OA is a radius. Even OB is a what? Radius. So OA is equal to what? OB. OA is equal to OB. The reason is what? Radii. Because they are both from center to a what? To a circle. OA is equal to OB. Radii. So we have this line from O to M. This line is joining two triangles. So we can say OM is equal to what? OM, common. So we can conclude that the two triangles are now what? Congruent to each other. So once the two triangles are congruent to each other, it means that they share equal what? Sides and what? Angles. Okay. Now we can conclude that AM is equal to what? MB. So there is this theorem number 2 which states that the angle at the center of a circle is twice angle at what? Circumference. Here we will be proving that angle BOC is twice angle what? A.